There we go. Hey everybody, my name is Sherry Seligson. We had some hard time getting on here. Whenever I do outside, I think we have a really strong Wi-Fi connection from our house. And for some strange reason, even though I turn off my Wi-Fi on my phone, it keeps trying to connect back to our house. So I'm hoping this goes really well. Let me know if you're jumping on, and let me know if this is working. If it stops working or something, we need to try to do some other stuff with our settings. Anyway, we're outside because I wanted to talk a little bit more about the bioluminescence. We learned about bioluminescence 2 days ago on Wednesday, and I changed gears. Yesterday we talked about echinoderms, which is another ocean type of creature, but I needed to change ideas because I wanted to get this stuff because we're going to make some glow-in-the-dark slime, and I didn't have this at home, so I went ahead and ordered it, and it was overnighted to me on Amazon. So I'm trying to use stuff you have around the house. I don't have this stuff around the house, but this is something I could get really quickly, and it came yesterday, so we could do this today. So we're going to talk more about bioluminescence, particularly about how organisms have to glow or create that glowing ability so that they can find one another or camouflage. We talked about all the different reasons why they do that, so they can hunt, like we made our anglerfish, our deep sea anglerfish. And I wanted to show you how light doesn't penetrate very well through the ocean. And so thank you so much for letting me know. It looks great. Thank you. All right, so we're going to make a slime recipe using very simple stuff. This is the only major ingredient that's kind of hard to find, and this is the Elmer's glow-in-the-dark glue. And so I'm going to use let me do a half-size recipe. It calls for 5 ounces of glue, which is this whole container. I'm going to use half of it, and we're going to just mix it together. So let me just add this in. I want about half of my container. That's about half right there, actually. All right, and then we're going to add a 1/4 teaspoon of baking soda. Now, I'm going to talk about the chemistry, about the chemistry involved once we start this mixing together. So a 1/4 teaspoon of baking soda. Remember, we're doing half recipe. I'm going to mix that in together. And you can kind of see, it's 1/4 teaspoon of baking soda and 2.5 ounces of my glue. And then we're going to take contact lens solution. Make sure it's all mixed well. We're going to use a 1/2 tablespoon of contact lens solution into it. All right, 1/2 tablespoon, which is 1.5 teaspoons. Got to know your kitchen chemistry too. There's a teaspoon. Here's a 1/2 teaspoon. All right, and then we're going to mix it and watch the consistency as I go. This is going to create a slime. Can you see almost instantly it's starting to get solid, not solid, but less goopy, less slimy. What's happening is the glue itself is slimy because it's made up of long chains of molecules. We talked a couple weeks ago about what molecules are. If you think of Legos, each Lego cube as being an atom, everything is made up of atoms. And when you connect atoms together, you get molecules, depending on the different kinds of atoms you stick together. Now, you can see how mine's getting nice and solid. I'm going to add a little bit more of my lens material, contact lens material, because I want a little more solid, less goopy. And so the glue itself is gluey because it's made up of long strands of these molecules. Let me pull it out. We can see we can knead it together now. Oh, it's still really goopy. Yeah, it's really goopy. Let's add some more. This is supposed to be slime we can actually hold in our hand and stretch. I'm making a big mess. Anyway, so this is fun. All right, so what's happening is, let me talk about the chemistry behind this with my pink gooey hands. All right, what happens is the glue material is made up of long strands of proteins, and so these you can imagine as long strands of proteins, and they slide past one another back and forth. And so when we add the actual eye material, it's made up of molecules that have clamps on the end. So I have these 2 clamps, And so we add the baking soda that makes these clamps open up. And those clamps actually cling to the different strands. One on this side. Look at my awful hands. I'm going to wipe them off on a towel because my hands are so goopy. Isn't this? Oh, well, we'll get messy. Science is messy and it's fun, right? Okay, so you can see how the clamps will hold together, and when you put lots and lots of clamps together, it makes all the strands kind of bind together and that they don't run past each other. And so that's what's going on chemically. The baking soda helps to hold it together. I'm going to add a little bit more. See if I can't get this to get a little more congealed. And then I want to hold it up to the light, or to the camera in a container, and we'll see if it glows. Because what we want to do is we want to look and see how this material will survive down in the water. We're going to drop it down in the lake. And so I want you to see how it looks glowing, and I'm hoping it'll do the same thing when we stick it down under the water. All right, so very messy, slimy experiment. Let me get all the air out. And then I want to stick it in, because you really can't see that it's glowing. I'm going to stick it in a bag, and let's see if we can see it glowing when I hold it up to the camera. Let's try. All right. Can you see that glowing? It's a little bit. It's kind of hard to see, right? Okay. Yeah, okay, we love making slime too. All right, so anyway, we're going to try this in two ways. We're going to drop down a glow stick. And we talked about how bioluminescent organisms make their own glowing because they take energy from a chemical reaction. And there's two different chemicals in this glow stick. There's a chemical inside the glass vial, and there's a chemical outside the glass vial. When we bend it, we break the little glass vial and we shake it and it makes that glow. What's happening with our glow-in-the-dark energy here is there's molecules here that take energy from the sun and light, and it excites the electrons from that light. And so that's eventually those electrons lose their energy and they release that energy in the form of light energy or glowy energy. And so they're both being excited, but this is excitement from chemical reaction. So let me break it apart, shake it up. Okay, you can see it's all glowy, and then we're gonna stick it in the lake. Now first, because I don't wanna just throw garbage in the lake, we're going to tape this so that we can retrieve our experiment. Okay, and then I'm going to get my camera helper, and we're going to see how long we can see this as I drop it down. Now, it's not very deep where I am here. All right, here we go. And it's floating. There it goes, there it goes. Can you guys see that? You can still see it, can't you? But you can't see it as well as you could see it before. Can you guys see? Tip it a little bit more, Dave. Tip it more. There you go. You guys able to see that? I'm gonna make it bob a little bit. It's about 5 or 6 feet deep here because our lake water is pretty low. And so you can see that it's harder to see because, let me pull it back up and then take a look at me now. I'm going to talk to the camera again. There we go. Because light doesn't penetrate very well as it goes through the water. We'll talk a little bit more about light and the properties of light next week. But light doesn't penetrate deeply in the water, and because of that, organisms have to create their own light. And so that's what they do with the bioluminescence. Now we're going to try it again, and this time we're going to try it with our glowy material that we just made. So I have it in the bag, and I have a little clamp on the bag, so I'm going to tie it to the clamp. And then I'm actually going to tape it because I really don't want to have to jump in the lake to retrieve it. If for some reason it gets caught in the lake, we can jump in, but we don't want to do that. And I'm also going to try to make sure I've got all the air out of this thing so it sinks. All right, so here's our glowy material. Let's see if we can see it in the water. Yeah, it's gonna float. All right, I'm gonna do something. I'm gonna open it up. Because these are food safe chemicals, let's see if that helps. You guys are giving me lots of likes. Come on, sink. There it goes, it's starting. It's like a mini submarine. It's kind of going down deeper. We can still see the pink. Can you tip it down a little bit more, Dave? Tip it. No, tip it. Just, yeah, there you go. All right. It's kind of working. It doesn't want to sink all the way. Okay, I'm going to pull it back up. Well, anyway, what I wanted to show you all of this is because when we talk about organisms deep in the ocean, we see that they have mechanisms to be able to communicate to one another, to find one another when it's time for reproduction, to be able to find their food, to be able to hunt other organisms, to be able to camouflage and hide from organisms. And so they use their chemical bioluminescent ability to create light in those photophores. If you didn't get a chance to see this, we did it 2 days ago. It was Wednesday's episode where we actually talked about the bioluminescent abilities of organisms. And so I just wanted you to talk a little bit more about how light doesn't penetrate down in the water very well, and the deeper you go, the less light penetrates. In the oceans, it only goes to about 200 feet with clear water. And so below 200 feet, organisms have to fend for themselves without sunlight. There's no photosynthesis that occurs, and so they're only dependent upon food that comes down from the top, whether it sinks as a dead thing or whether they go up to the top to get it and bring it down. So thanks for joining me. We will come back again on Monday. We'll talk about some wonderful things again. I'm really excited to be able to do this. Have a wonderful weekend and happy Easter, everybody.